All right, let us discuss about implicit differentiation. So there are two types of expressions. The first one is explicit. So the first one is explicit expressions. Explicit expressions have the dependent variable explicitly isolated on one side of the equation. So you are familiar with this one, right? For example, they are written in the form y is equal to, y is equal to f of x. That is, there is an input and output relation. For example, f of x is equal to, let's say, 5x plus 2. That is, there is the input and this is output, right? That is, we know how to find the derivative of such kind of expression. However, there are other expression we call them implicit expressions. In this case, those expressions have the dependent and independent variables mixed together. These have the dependent and independent variables mixed together in the equation, so that we cannot isolate y in terms of x. So they are written in the form of a function f x y is 0. For example, equation of a circle. For example, equation of a circle, let's say x squared plus y squared is equal to 1. This is one example. Another example, for example, let's see b f x in terms of xy, x squared minus 2xy plus 3y squared minus 5. So in this case, we cannot explicitly write one variable in terms of the other. In that case, we call it implicit expression. Now, our objective is how to find the derivative of such implicit expression. Now, let's see an example of such type of implicit expressions. Example, let's say 1, given f of x y is x squared plus y squared minus 25 is 0. This is explicitly given. So let's find y prime, but we can isolate y prime, and also we can find the slope of the graph at x is equal to 3. Now, in order to solve this one, look at x squared plus y squared is minus 25 is equal to 0 is a circle. Let's start with drawing the graph. Let us start let us start by drawing the graph of x squared plus y squared is equal to 25. This is a circle equation with radius 5. That is, for example, if you draw, this is the y, this is the x, and the circle. Let me draw a circle. All right, so this is the equation of a circle. This is x. So this is equation of a circle. X squared plus y squared is equal to 25. The radius is just 5. And there is a point now here, x and y. Now, what is the value of y when x is 0? Because in this problem, find y and the slope of the graph at x is equal to 3. So let us find y when x is equal to 3. Now, we have to substitute into the equation. 3 squared plus y squared is equal to 25. This is y squared is equal to 25. You know, this one is 9 minus 9. So we have y squared is equal to 16. And this implies that y is equal to plus or minus root 16, which is y is plus or minus 4. So we have 2 pointers. Now, the point, you know, 3, positive 4 is on the upper half circle, and the point 3 minus 4 is on the lower half circle. So when you indicate this one, there is a point, for example, here, there is a point 3, 4. The other point is symmetric, and 3, negative 4. So we have 2 points. That is upper one at 3, positive 4. The lower one is 3, negative 4. Now, how do we get the derivative of y prime? So in this case, take, you know, d by dx, both sides of the equation, and you have to apply the chain rule. For example, in our case, d by dx of, you know, x squared plus y squared equal to d by dx of 25. Now, when we take the derivative, the first one is d by dx of x squared plus d by dx of y squared. Remember, d by dx of 25 is just 0. We know that d by dx of x squared is 2x. But the second one, you know, I just take the derivative with respect to y squared. So it is 2y, y prime, or dy by dx is 0. Now, from this, you can see that we can solve for y prime. So 2y, y prime is minus 2x. Here, y prime is minus 2x divided by 2y. This implies that, you know, when you simplify this one, it is negative x over y. Now, we see this is implicit differentiation. Now, the question is to find the slope at the 2 pointers, because there are 2 pointers. The first one is y prime at 3, 4. That means when x is 3 and y is 4, now I have to substitute minus 3 over 4, which is negative 3 over 4. So this is generally the slope at 3, 4, right? The second one is the derivative or the slope at 3, negative 4. It is 3 negative is negative 4, which is positive 3 over 4. So this is the slope at 3, negative 4. So we have two slopes. Remember the previous circle, or let's draw another circle, the same, this one, and the circle is, let's see, draw a circle. Now the first one is, there is a point 3, positive 4, corresponding to this one. Also there is another point 3, negative 4. So the first slope is, when you draw this one, here is the slope. The other one is, here is the slope. So the slope of this line is, according to our calculation, it is negative 3 over 4. You can see that it is a negative slope, and the slope of this line is positive 3 over 4. You can see that this is a positive slope, right? It is increasing. So this is an example of implicit differentiation. So I'll come with more examples on my next video.